All right, guys, so today we're going to introduce a few more exponent rules. And the big one we're going to talk about today is a power raised to a power. So if we look at example 2 here, we have a to the third power, and a to the third power is being raised to the second power. Okay, so basically what's happening here is it's two iterations of a to the third power. Okay, so what does that mean? We know that a to the third power is the same thing as a times a times a. Okay, but if I'm squaring a to the third power, it's basically two iterations of what I just wrote in parentheses. So it's another a times a times a. Okay, and if we're trying to figure out what this is written as one exponent, what do we see? We see 1, 2, 3, 4, 5, 6 iterations of a. This is the same thing as a to the sixth power. Okay, so what's the rule? If we have a power raised to a power, 3 raised to the second power, all we're going to do is we're going to multiply the exponents. So what that means is if you have a to the m power raised to the nth power, in order to simplify this, it's the exact same thing as a to the m times n. So if we do a few examples of that, if we have 5 squared to the fourth power, this should be the exact same thing as 5 to the second power times 4, or 5 to the 2 times 4. And 2 times 4 is equal to 8. This is the exact same thing as 5 to the eighth power. Okay, this easily applies to fractions as well. We just got to make sure we're being precise when we multiply these fractions. This should be the exact same thing as a to the 1/2 times 3/5. So remember, when we multiply fractions, we want to multiply straight across. My numerator should be 1 times 3, which is 3. And then my denominator should be 2 times 5, which is 10. a to the 3/10 power is my final answer. All right, for the next one, if we're raising a product to a power, okay, for example 3 here, we've got this ugly -4a cubed b squared c cubed, and everything inside of here is being raised to the second power. Okay, so what this means is this entire thing that's inside my parentheses here, there's going to be 2 iterations of that. So if we were to write that as a multiplication question, it would look like this. It would look like -4a cubed b squared c cubed, but just 2 iterations of it. So the exact same thing over again. -4a cubed b squared c cubed. Okay, and if we wanted to simplify this, basically it just becomes a multiplication question where you're squeezing the numbers with the numbers and you're squeezing the letters with the like letters. So the first thing I see here is I see -4 times -4. Negative times a negative is a positive. It should give me positive 16. Okay, combining the a's with the a's. I see a cubed times a cubed. Same base, add the exponents. 3 plus 3 should be equal to 6. It should be a to the 6th power. I got b squared and b squared. Add the exponents with the same base. 2 plus 2 is 4, b to the 4th power. And the last piece I see here is c cubed times c cubed. 3 plus 3 is equal to 6. It should be c to the 6th power. Okay, that is the cleaned up version of that guy right here. But the easier way to think about this is rather than pulling it apart, what we could easily do here is we could easily just raise each exponent to the power and then multiply. Okay, so what that means is basically you're going to distribute the exponent to each piece. So if you have a times b raised to the mth power, this m is going to distribute as an exponent to each specific term. It's a to the mth times b to the mth. And then just a and b are not allowed to equal 0, and n is a rational number. Okay, so we do some examples of this. The first one we see here is 9xy squared. The easiest way to do this is just take 2 and distribute it to each specific piece as an exponent. It should be 9 squared, x squared, and then y squared. And then you can typically clean these guys up because 9 squared is not the best way to write that number. 9 squared is the same thing as 81. 81 squared y squared is my final answer in simplest form. Okay. Same thing kind of applies for b still. I'm going to take this 4 and I'm going to distribute it to each specific piece. Okay, what I'll have here is I'll have -3 raised to the 4th power, and then z raised to the fourth power. When you're dealing with negatives, you got to be careful to make sure that sometimes your signs can change. So if we have negative 3 raised to the fourth power, it's 4 iterations of a negative number. It's a negative times a negative times a negative times a negative. And if it's an even number of negatives, this thing is going to become positive. So if you have negative 3 raised to the fourth power, if you plug this in your calculator, you should get positive 81. And then z to the fourth kind of just stays as is, z to the fourth power, like so. Okay, now if we compare it to c, a little bit different. We got the negative in front, and then some parentheses, 4w, and then only the 4w is being cubed. Only the 4w is being raised to the third power. So if we do this, we got to account for order of operations. We got to account for the exponent first. This 3 is going to distribute to each specific piece. I'll have this negative, and then in parentheses, I'll have 4 cubed, w cubed. Okay, and I know that 4 cubed, if you plug in the calculator, it should give you 64. I still have a w cubed, but that negative is still out in front. Okay, I haven't touched it yet, so all this negative is going to do is it's going to come down, and it's not going to go anywhere. So my final answer should be negative 64 w cubed. This entire quantity is basically being multiplied by negative 1. Okay, now example D, it looks pretty complicated, but let's see what we can do with this. So inside here, I see 4 squared in my first set of parentheses. Okay, I can actually clean that up immediately. I know that 4 squared is the exact same thing as 16. So I could change whatever's inside of here into a 16. But 16 is still being squared, and then 16 squared is still being raised to the third power. Okay, so what can I do? Order of operations allows me to just, okay, I could work from the inside out. The next thing I see here is 16 squared. 16 squared, if you plug in the calculator, you should get 256. Then 256 inside of brackets, all of this is being raised to the third power, and you should get a pretty large number. It's something like 16 million. I believe it's 777,000. I believe it's 216. Pretty large number. But exponents make numbers get really big really, really quickly sometimes.